I'm Anil Kumar, and here is compilation of few videos which I thought now at the end of the year my grade 10 students can take up as a review challenge. And I hope and wish that those students who are even getting very close to 100% marks find it interesting at times. So the idea of having questions here is not just give you very difficult questions, but also to remember and appreciate the concepts which we have learned. The very first we'll start with the let's say writing equation. So let us say if I have a question and I have to write an equation for, I should say an expression for 5 less than a number, then what is my expression? So that is at times I have seen very challenging for some students. Some of the students will write let the number be n and the answer is 5 minus n, which indeed is not the correct answer, correct? So the answer here is let the number be n and 5 less than means minus 5 comes later, right? So that is kind of a very simple thing, but it is challenging. If you are not reading it properly, you always get that wrong. So the challenge series which I have necessarily will not have very difficult questions, but will have tricky application type of thinking questions which will help you to review and learn better. Okay. Second question, let me now get to the equations part, right? My equations part question is that product of two, let's say consecutive odd integers, okay, odd integers be 323. So let's say that is my question. Now that is really a challenging question at times because some of the students do not understand the term two consecutive odd integers, right? So that is how it becomes very challenging, correct? So writing equation for this equation could be very tricky. I do have a video, I'll provide you with the link. But here is the neat thinking part of it. When you are looking for product of two numbers, that too very close by, that means if I do square root of 323, what do I get? I get square root of 323 as 17.97. So how about trying 17 and 19? Okay, so try it out. If you do 17 times 19, do you get the result? So at times, if you get such a question in a multiple choice question, these small tricks can help you get the answer quickly. That's the whole idea about this challenge series, and I hope you're learning and also appreciating. Okay, we will now move on to simultaneous equations or linear systems. In linear systems, the examples which most of you have done so far will involve simple linear equations, but I can twist them around. For example, if I give you equation 1 over x plus let us say 3 over y equals to 3 over 4, and the other equation is 3 over x minus 2 over y. I'm copying this equation from my example. Then what really happens? Well, it doesn't look like a linear equation. You have x and y in the denominator. That's tricky, right? So these are challenging questions which we are talking about. I'll provide you with the link of this also to look into the real solution. But here is the trick. The trick here is that what you can do is you can write 1 over x as equals to a and 1 over y equals to b. Then it becomes a linear equation. Do you get the idea? So it becomes a linear equation which you could solve, right? So that is what I mean when I'm talking about this series, and then you can solve and check your answer. Again, I'll provide you with the solution of this particular question also. Now as we move from linear systems, we'll have a few more examples. I'll give the link for them. Okay, let's talk about coordinate geometry, where we are talking about midpoint. Probably the easiest chapter you must have come across. But in midpoint, what I will do is we'll talk about a segment, and I will say, well, let this point be minus 10 and 5, and this point, the midpoint, is given to you. So I'll give you the midpoint, and I say my midpoint is 2 and let us say minus 7, but you find the end point x and y. that makes situation difficult for some, right? Well, not for my A plus students, but for most of them. Okay, so that could be challenging at times. So these are the type of questions which you need to explore now, since you are at the end of grade 10 and you are preparing for final exams. Okay, now if you move forward, we'll say circumcenter. Okay, that is kind of very critical. So what I can give you now, a question based on circumcenter is that I can give you a multiple choice question, right? And I say, well, I do have a triangle, and let me make one triangle here, and this happens to be a right triangle for me, correct? And I say, let us say this is some point, let's make it simple, right? 0 0, and let me take this point as, okay, of course 0 and 4, and this will be, let's say 3 and 0, right? So let's say we have this particular triangle and you need to find the circumcenter. Now that could be very challenging, and you may have to find, you remember what circumcenter is, you have to find the perpendicular bisectors of each side, and the point where they intersect is the circumcenter. And from circumcenter, if you draw a circle, then it should go through all the three vertices of the triangle. That is what we learned about circumcenter. And what is so cool about the right triangle? Well, you just have to find this midpoint, and that is your answer, right? So in this case, the answer is, if I add then divide by 2, I get 1.5, add y is divide 2. That is my answer. So at times, especially in multiple choice questions, this could be very, very interesting and handy. So that is how my challenge series is connected. If you are liking this idea, you should go move forward and check out those few videos which I have included and different questions which I have for you, right? And also we'll have some application questions based on this. For example, if through a forest they want to lay down some road, right? And there is some road and there are a few houses nearby. Let's say one house location is given here, the other one somewhere there, and somewhere there. So from where the road should go and how should they be connected so that all are same distance apart. So how do you find those kinds of points? So we could have a gas station at that place. Perfect. So something like this. So those questions will involve what you have learned in coordinate geometry, correct? So let's move on to trigonometry now. And few examples in trigonometry will be, well, I've not talked about area. Oh, okay. So we'll talk about area. We'll say very simple. How about area of an equilateral triangle? So we'll say area of an equilateral triangle, and I'll give you let us say sides be 2 centimeter each. Okay, 2 centimeter each. In that case, just find the area of the triangle. Well, the answer is very easy to find, but it is very tricky. So that is indeed a challenging question, right? So we'll look into questions like this. Think about it. I could join it with similar triangles, and I say, well, if there is another equilateral triangle whose sides are in the ratio of, let us say, 5:2, then find area of that triangle. You remember, side ratios will be squared when you're talking about area, correct? So talking about geometry and coordinate geometry, we could say, well, if I have a pipeline going and the diameter of the pipeline is given to me, for example, if I say the diameter of this pipeline is 5 square root 2, in that case, somehow I want to fit in a square. I want to fit in a square in it. Let's say something like this. So what could be the maximum area of the square which can exactly fit into the pipeline? So that could be a very interesting question which may involve Pythagorean theorem, right? So you understood a square plus b square equals to c square, and may involve trigonometry at times. So those are the type of questions which you will get in my series. Or when talking about the area of triangle, I can make it even more interesting if we consider a case that I say, well, let us have an isosceles triangle, and in the isosceles triangle I make a circle. Okay, imagine this is a beautiful circle with, let us say, radius 2 is a good number to take. Easy to work with, right? Let us say easy to work with circle radius, and it is like inscribed in the triangle. The circle is inscribed in the triangle, and I give you the angles of this isosceles triangle. Let us say these angles are 65 degrees, right? And I also give you the base of this. Okay, doesn't matter. If I give you the base also, let us say this is 15 centimeter. Oh no, it could not be. Well, we'll have to work out. It could be some other thing. I don't have to, since I have given you this. Okay, that is not required, so I won't give you. Perfect. So what I give you really is the angles here and the area, and I say find the area of the triangle. That could be really challenging, and then to challenge you further, we will have questions like you've seen in the book, right? We have three circles, one bigger than the other, and the other one even more bigger, right? So let's say even more bigger, okay? And we give you some radius for each. I say this is, let us say 2 is a good number, right? Easy to work with. 2, and this is 3, and let us say this is 4, okay? So we say these are the radius of these three circles, okay, put together. I now need the area of the center portion, the open space which I have in between. How are you going to do that? Well, that will require area of the sector of a circle. So those are the type of questions which you may have to work with. And some relatively easy questions could be, in this particular set of videos, is finding area of a scalene triangle. So what I can do is I can just draw a triangle like this, okay, and give you 3 points, correct? And I say, well, let this be the triangle, and I'm giving you points which were given to me by one of my. So this is a scalene triangle, and let me give you the coordinate points which my subscriber gave me, right? So these are really tough points to work with, and let this be, let's say, minus 1, 6, and let this point be 1, 10, and this point be 4, 1. Well, I could have written any points for these 3 vertices, but anyway, take these points. I do have an example which is solution of this question, so that will help me to link it up. So anyway, so we have a scalene triangle, and you need to find area of this triangle. You can use trigonometry or coordinate geometry as you wish to solve this particular question. So you need to drop a perpendicular from one of the points and then find the distance, right? So that may involve minimum distance from a point to a line. Do you understand? So that could be the concept which you can apply, and that makes this question a bit challenging. So whenever we apply one concept into the other, then it might become difficult at times. Let me take the last example now. We're making a lot of circles. Let me make one more circle. The idea is now to find equation of, my question now will be equation of tangent to the circle from a point. Now, how do you do that? So that also involves a lot of concepts, right? So that could be another question. And let us say, for simplicity, we'll take circle which is right there from the origin, and if you know what the radius is, okay, so it becomes easier for you to solve, right? So you can take this question up, and let me take a point here. For example, let's take a circle whose radius is 5 units, right? So we know 3, 4, 5 will be a point on the circle, and since it is 5 and this is also 5, let me take a point which is slightly away, and let's say this point is 10 and 7. Now you need to find equation of tangent from this point to this circle with center at origin and of radius 5 units. So these are the type of questions which I'll be considering in this challenge series, and I'll involve some more questions on exponents and things which I have not talked about, and I hope that is going to give you a good practice for your final exam. All the best to all of you. Thank you, and I hope you enjoy this journey with me.